Hey everyone. So, you write code, right? But have you ever wondered about all the machinery humming away behind that code? We're about to go on a journey, moving past just being a code implementer and becoming someone who really understands the why of system design. Let's get into it.
Ah, yes, the six most dreaded words in all of software development. It works on my machine. We've all said it, we've all heard it, and yeah, tools like Docker helped fix this for our code, but what about the bigger picture? The architectural problems are still out there, and that's what we need to tackle.
So, this is our mission for today. We're going to go from just watching architectural decisions get made to actually being part of that conversation. It's about learning the language, understanding the trade-offs, and really starting to think like an architect. We've broken this down into 6 key areas. We're going to start with the absolute foundation, your data. Then we'll hit an impossible choice every system faces. We'll look at how services chat with each other, how to build a solid core for your code, how to plan for when things inevitably break, and finally, how this all comes together in the cloud. All right, first things first. Before you write a single line of application code, you have to ask the most important question of all. What does my data actually look like? The answer to this question is the bedrock for everything that comes next. So, when you're storing data, you've basically got 2 main flavors. On one side, you have SQL. Think of it like a super strict Excel spreadsheet. Every row has to fit into predefined columns. This is amazing for things like banking, where you absolutely cannot have messy or inconsistent data. Then you have NoSQL. This is more like a folder full of random documents. Each document can have its own structure. It's perfect for things like a content management system where you have all sorts of different data types living together. And this choice leads to a massive trade-off. SQL databases promise you ACID guarantees. It's a simple promise. The transaction will be perfect or it will fail completely. Think about a bank transfer. It has to be all or nothing. But many NoSQL databases make a different promise, base. They promise the system will basically always be available, even if it means the data isn't perfectly up to date for a few seconds. It will be eventually consistent. That's a trade-off many social networks are willing to make. So why can't we just have it all? Why not a database that's always perfectly correct, always online, and works perfectly across the globe? Well, there's a fundamental law of physics for distributed systems that says you can't. It's called the CAP theorem. So here's the deal. The CAP theorem says you get 3 options. Consistency, meaning everyone sees the same latest data. Availability, meaning the system always responds to requests. And partition tolerance, meaning the system keeps working even if parts of the network fail. The catch? You can only pick 2. Now here's the secret that changes everything. In the cloud, the network will fail. It's not an if, it's a when. So partition tolerance, the P, isn't really a choice, it's a requirement. You have to pick it. That means your real choice is between consistency or availability. Are you building a CP system, like a bank, that would rather shut down than show an incorrect balance? Or are you building an AP system, like social media, that would rather show you slightly old data than an error page? This is one of the biggest decisions you'll make. Okay, so we've got our data stored. Now, how do we get different parts of our system to actually talk to each other? That's where APIs come in. But not all APIs are created equal.
Think of these as different ways to have a conversation. REST is kind of the universal language, the standard everyone understands. GraphQL is like being a super specific selector. You ask for exactly what you need, no more, no less, which is amazing for mobile apps. gRPC is the speed demon. It's incredibly fast for internal services talking to each other, but it's not something a human can easily read. And then you've got WebSockets, which are like an open phone line, perfect for real-time stuff like chat apps or live sports scores.
Okay, so our services are talking, but what about the code inside each service? You see, a huge mistake people make is mixing their core business rules with things like database code. It creates a tangled mess that's a nightmare to change. But, there's a much cleaner way to do it. It's called clean architecture. And the golden rule is so simple. Dependencies always point inward. Imagine your pure business logic is in a protected fortress at the very center. It doesn't know or care if you're using a SQL database, a REST API, or anything else. All those external things are adapters on the outside, and they have to talk to the business logic on its terms, not the other way around. And why do we do all this? The payoff is huge. Your core business rules are now totally separate from your technology choices. You want to swap out your database from Postgres to something else? Go for it. The core of your application won't even notice. This makes your system incredibly robust and, best of all, super easy to test. Now, let's talk about a real mindset shift. Junior developers hope things don't fail. Senior developers know things will fail, so they plan for it. This is about building systems that can take a punch and keep on going. Here are 3 patterns you absolutely need to know. First, the circuit breaker. If one of your services is failing, the circuit breaker trips, just like a fuse in your house. It stops you from hammering a service that's already down. Then there's exponential backoff. If a request fails, don't just retry immediately. Wait 1 second, then 2, then 4. Give the system a chance to breathe and recover. And finally, idempotency. This is a fancy word for making sure an action is safe to repeat. It's why you don't get charged twice if you accidentally double-click the Buy Now button. So, we've talked about data, communication, and code structure. But where does all of this actually run? In today's world, your architecture and the cloud infrastructure it runs on are basically 2 sides of the same coin. Let's make this simple. Docker puts your code in a neat little box, solving the "it works on my machine" problem once and for all. Kubernetes is the giant automated cargo ship that manages thousands of those boxes for you. It handles scaling, heals them when they break. It's amazing. And then there's serverless. This is the next level. You don't even think about boxes or ships. You just upload a piece of code, a function, and the cloud runs it for you whenever it's needed. It's like magic. Okay, after all of that, you're probably buzzing with questions. Should I use SQL or NoSQL? REST or GraphQL? Do I build one big application or lots of tiny ones? What's the right answer? And if you ask any experienced architect, they will give you the same infuriatingly simple answer. It depends. But listen, this isn't a cop-out. It's the most important lesson in all of software architecture. There is no single best way. The right choice is always, always about your specific context. See, the goal isn't to memorize a bunch of answers. The goal is to learn how to ask the right questions. How big is your team? What's your budget? How many users do you expect? How fast you need to ship? These are the questions that guide your decisions. With what we've covered today, you now have the framework to start asking these questions and to truly participate in finding the right answers for your project. The only question left is, what trade-offs are you going to make?